Hi guys, you're welcome to God Academy. This is the second lesson in our differential equation course. In this lesson, I'll be taking you through the solutions to differential equation. In our previous lesson, we went through the overview, talk about all the different classifications of differential equation, and we solve examples as you saw. Now in this lesson, we continue. Now, when we talk about solutions to differential equation, what do we mean? The goal of differential equation is to find a solution to the problem. Is that not it? But now here comes different forms of solution required. There are two main types of solution we'll be talking about in this lesson. We have what we call the general solution, then what we call the particular solution. Some literature say the actual solution. What do we mean by general solution? What do we mean by particular solution? Differential equation is simply solving a derivative or reversing a derivative. Therefore, we can say that it's actually integration. The whole differential equation is all about you integrating something. Okay, therefore whenever you do an integration, remember there is an introduction of what you call a constant of integration. Okay, a constant of integration means that there are so many possibilities depending on the value. So let's do this simple integration. So integral of 2x dx, what's the answer? This becomes what? X squared plus c. The c here can give us countless number of functions. If c is 1, our function become x squared plus 1. If c is negative 5, our function become x squared minus 5. Meaning that this is what we call a general solution because it is not specific. Depending on the conditions given, that will restrict or that will make this a simplified or a specialized solution. So a constant of integration, which we introduce in our differential equation, give rise to what we call a general solution. Now, you can convert a general solution to a particular solution by applying conditions. So conditions such as y of 0 is equal to 1, y prime of 1 is equal to 0, or y prime prime of 0 is equal to 5. These are conditions which help us to find the value of our constant c in any differential equation to give birth to what we call a particular solution. So whenever they give you y of 0 is equal to 1, y prime of 0 is equal to 2, this is what we call initial condition that occur at t, at x, at when your independent variable is 0, is simply what we call initial condition. Initial conditions. So initial conditions is talking about the state of your dependent variable when the independent is 0. Equations which equation that comes with initial conditions are simply called initial value problems. Initial value problems. So initial value problems are differential equation problems which has initial conditions attached to the equation. Okay. Now, we also have what we call the boundary value problem. Boundary value problems. So here, you don't necessarily give you initial conditions, but we can give you y prime of 5 is equal to something. This gives the boundary of a differential equation, and we call them boundary value problems. Now let's have this problem solved and see how to test. So I have a problem. It says that show that y of x is equal to x to the power negative 3 out of 2 is a solution to the differential equation 4x squared y prime prime plus 12xy prime plus 3y is equal to 0, where x is greater than 0. So they are saying that you should show that this here is a solution to this differential equation. How do you solve such a problem? Watch closely. Solve such a problem is just a substitution work. They've given you one solution, which is y of x. To solve this problem, we have y prime prime, y prime, and y to substitute to solve this problem. But how do we get y prime prime from our solution? We can get y prime prime simply by differentiating this twice. We can get y prime simply by differentiating this one. So let's see. Our y prime is simply going to be what? Let's differentiate this. Differentiating, I'm going to get negative 3 out of 2 x to the power x minus 1, right? When I subtract 1, I get negative 5 out of 2. Now let's check y prime prime. Y prime prime simply gives this, right? We are so y prime prime takes from here. We multiply this by this, we are going to get 15 out of 4, right? X to the power, when I subtract 2, I'm going to get negative 9 out of 2 because I'll subtract 1. Oh, sorry, negative 7 out of negative 7 out of 2. Having got this, I'll make my necessary substitution. So I'll simply have 4x squared multiplying my y prime prime is 15 over 4 x to the power negative 7 out of 2 plus 12 x multiplying my y prime is negative 3 out of 2 x to the power negative 5 of 2 plus 3, and my y is given as the equation as it was given, x to the power negative 3 out of 2 is equal to 0. So here is simple. 4 cancels this 4 here, right? As simple as that. So let me use this. So 4 cancels this 4, right? Now I have x squared and I have this. So 15 is 15, okay? You surely get 15 out. Then x. But the power becomes 2 minus 7 over 2. That gives me negative 3 over 2. Solve that. Negative 3 over 2. Then I come to this section. Plus, when I come here, I have x here. I have x here. 2 can cancel itself 1 and go into 12, 6. Is that not it? So I'll simply get 6 here. And this is negative 3 out of 2. So that is going to be negative 18. Negative 18 x. But the x is going to be 1 minus 5 over 2. And that is negative 3 out of 2. Then I come here, plus 3 x to the power negative 3 out of 2. And that is 0. This gives me 18 x to the power negative 3 out of 2 minus 18 x to the power negative equals 0. Obviously, 0 equals 0. Therefore, this is indeed the solution to the differential equation we just did. As simple like that. Okay. So, this is all about the solution to differential equation. We have general solution and we have particular solution. Okay. So, in our subsequent lessons, I'm going to solve all the different types of differential equations which you know, which we have the linear, the separable, the exact, the Bernoulli, and the substitution methods. So see you in the subsequent lessons. And don't forget to subscribe to help us achieve our 1K subscribers goal. Thank you.